Giza Plateau, Egypt. The Great Pyramid is arguably the most enigmatic structure on the face of the Earth. It is the only surviving wonder of the ancient world and has inspired endless speculation as to how it was built and what purpose it served.
Buried in the Great Pyramid of Giza is a secret older than recorded history. Not in hieroglyphs, not in scrolls. A number encoded in stone, carved with precision that defies everything we thought we knew about ancient humans. Pi, the golden ratio. The dimensions of the Earth itself, hidden in plain sight, 4,500 years before anyone could explain it. Who built it? How did they know?
Mainstream archaeologists theorize that the Great Pyramid was built sometime around 2500 BC as the burial tomb of the pharaoh Khufu.
And why leave a message in mathematics rather than words? Tonight, we follow the evidence, decode the numbers, and ask the question no one has answered for millennia. What were they trying to tell us? Measured by the gods. Let's start with what we can measure, because the most powerful argument for hidden knowledge in ancient structures isn't speculation. It's arithmetic, and arithmetic doesn't care about anyone's theory. And the Great Pyramid of Giza is oriented to true north, with an accuracy of 3/60 of a single degree. That's 0.05 degrees of deviation, or roughly 1/20th of 1 degree. To grasp how absurd that is, consider this. The Paris Observatory, built in 1667 under the direction of Giovanni Cassini, using the finest surveying instruments available to 17th century European science, is oriented to true north, with less precision than the Great Pyramid. The Royal Greenwich Observatory, constructed in 1675 as the navigational nerve center of the British Empire, also falls short. A structure completed around 2560 BC using copper tools, stone hammers, and no magnetic compass, outperforms the headquarters of the two greatest maritime empires in modern history. The alignment wasn't accidental. In 2018, engineer Glenn Dash published a study in the Journal of Ancient Egyptian Architecture proposing that the builders used the autumn equinox shadow method, tracking the tip of a gnomon's shadow across a carefully leveled surface throughout a single day to establish a precise east-west line, then deriving true north from the perpendicular bisection. The method is elegant and requires no technology beyond a rod, a cord, and sustained observation, but it demands something technology alone cannot provide: the knowledge that such precision matters, the institutional patience to achieve it over months of calibration, and the organizational capability to translate a line drawn in sand into the placement of 2.3 million limestone blocks across 13 acres of desert plateau with an average deviation across the base of less than 2.1 centimeters. And that last number is worth pausing on. Flinders Petrie, the founder of modern Egyptology, the man who essentially invented systematic archaeological measurement, surveyed the Great Pyramid in 1880 using the most precise instruments available in Victorian England. His measurements of the base, published in the Pyramids and Temples of Giza in 1883, revealed that the four sides of the pyramid differ in length by a maximum of 4.4 centimeters across a span of 230 meters. That is a construction tolerance of 0.02%. Modern skyscraper foundations rarely achieve that consistency. The Burj Khalifa in Dubai, the tallest building on Earth, completed in 2010 using GPS-guided laser systems and computer-modeled concrete pours, was built to tolerances that, proportionally, are not dramatically tighter than what the pyramid builders achieved with copper and limestone 45 centuries earlier.
Every single block needed to be cut by hand, using tools made from this copper. And since those tools would quickly blunt, a constant flow of the copper that came via Wadi al-Jarf was essential.
That is not primitive. That is engineering culture operating at a level we have systematically underestimated. And Giza is only the most famous example. Angkor Wat in Cambodia, the largest religious monument on Earth, constructed in the early 12th century AD by King Suryavarman II, but drawing on architectural and astronomical traditions far older, encodes the precessional cycle in its measurements. The distance along the main causeway from the western entrance gate to the central tower, measured in the ancient Khmer unit of the hat, yields a sequence of numbers that correspond to the durations of the 4 Hindu yugas, the cosmic ages, expressed in precessional units of 72 years per degree of axial wobble. Our Eleanor Manica, an art historian at the University of Michigan, published a detailed analysis of these proportional relationships in her 1996 book, Angkor Wat, Time, Space, and Kingship, documenting how the temple's dimensions systematically encode calendrical, cosmological, and astronomical data in its physical layout. Her work remains one of the most rigorous studies of metrological encoding in any ancient structure. Stonehenge in Wiltshire, England, is aligned to the midsummer sunrise and midwinter sunset along its main axis, a fact that has been recognized since at least the 18th century, when William Stukeley first documented the solstitial alignment in 1740. But more recent work by the late Alexander Thom, professor of engineering science at Oxford, revealed something far more significant. And through decades of fieldwork surveying over 500 stone circles across Britain, Ireland, and Brittany, Thom identified a unit of measurement he called the megalithic yard, approximately 2.72 feet, that appears with statistical consistency across sites separated by hundreds of miles of open ocean. His surveys, published across multiple volumes including megalithic sites in Britain in 1967, demonstrated that the builders of these monuments were not working in isolation. They were part of a system, a cultural network that shared a standardized unit of measurement, a common geometric vocabulary, and a consistent astronomical orientation across thousands of square miles of territory, centuries before writing arrived in Northern Europe. These aren't decorative flourishes, and these are engineering decisions requiring abstract mathematical knowledge, precise astronomical observations sustained across generations, and institutional infrastructure to train, organize, and deploy specialized labor at scale. And they appear again and again in cultures that, according to the standard model, hadn't invented the tools to make them possible. Either the timeline is wrong, or the tools were different than we assume. Neither option is comfortable for the conventional narrative. But the measurements don't lie. And the measurements have been checked by Petrie, by Thom, by Dash, by Manica, by teams with modern instruments returning to ancient sites and finding again and again that the precision holds up. The builders knew exactly what they were doing. The question is how. Civilization before civilization. Here is the uncomfortable truth that Göbekli Tepe forced into the open and that a growing body of evidence continues to reinforce.
It was built 11,500 years ago by hunter-gatherers. That's 6,000 years earlier than Stonehenge. And yet somehow our ancestors were capable of making this. Göbekli Tepe.
The history of human capability does not follow a straight line. We talked about Göbekli Tepe in another context, but its implications reach far beyond southeastern Turkey. A monumental temple complex built by hunter-gatherers 12,000 years ago, before agriculture, before pottery, before metallurgy, proves that organized, large-scale, symbolically complex societies existed far earlier than the traditional model allows. Klaus Schmidt, the German archaeologist who excavated the site from 1995 until his death in 2014, said it plainly, "First came the temple, then the city." But Göbekli Tepe didn't emerge from nothing. A project of that scale, 22 acres. Pillars weighing up to 15 tons, carved reliefs of extraordinary sophistication, implies generations of accumulated knowledge. It implies tradition, predecessors, a culture that had been developing its skills, its symbols, its organizational capacity for centuries or millennia before the first pillar was raised. Where is that predecessor culture? We don't know. It left no structures that we have found. It left no texts. Writing wouldn't be invented for another 6,000 years. If it existed, and the existence of Göbekli Tepe strongly suggests that it did, it was erased by time, by ice, by rising sea levels at the end of the last glacial period, when coastlines around the world retreated by hundreds of miles, and the landscapes where coastal civilizations would most likely have developed were swallowed by the ocean. And it may have been erased by something more sudden than gradual flooding. In 2018, an international team of researchers led by Mario Pino of the Universidad Austral de Chile published findings in scientific reports identifying a platinum anomaly and nanodiamonds in sediment layers dating to approximately 10,800 BC at the Palauco archaeological site in southern Chile. These signatures are consistent with the Younger Dryas impact hypothesis. The proposal, first advanced by Richard Firestone of Lawrence Berkeley National Laboratory in 2007, that a comet or asteroid fragment struck the Earth around that date, triggering a catastrophic return to Ice Age conditions that lasted over 1,000 years. The Greenland ice cores confirm the temperature collapse. The megafaunal extinctions across North America coincide precisely, yet the geological layer is real, measurable, and global. If a civilization existed before the Younger Dryas, and Göbekli Tepe proves that sophisticated cultures existed during or just after it, that event would have been an extinction-level catastrophe for any low-lying coastal society. This is not speculation. It is geology. Sea levels rose approximately 120 meters between roughly 19,000 and 7,000 BC. That is nearly 400 feet of vertical flooding. Every coastal settlement, every harbor, every low-lying city built during the late Pleistocene is now underwater.
The Pleistocene is the Ice Age.
If it existed at all, and there is evidence that it did. Off the coast of Gujarat, India, marine archaeologists from the National Institute of Ocean Technology discovered submerged stone structures in the Gulf of Khambhat in 2001. A side-scan sonar revealed geometric formations, walls, foundations, channels, spread across an area of roughly 9 kilometers. Dredged material from the site included artifacts that were carbon-dated to approximately 9,500 years ago. The site remains controversial. Some scholars question the dating, others question whether the formations are genuinely man-made, but the physical evidence is there, sitting on the seabed, waiting for better technology to settle the argument. Off the western tip of Cuba, in 2001, Paulina Zalitsky's advanced digital communications team detected sonar anomalies at a depth of roughly 700 meters. The images showed geometric formations, apparent pyramids, rectangular structures, and what looked like streets, covering an area of roughly 2 square kilometers. At that depth, the structures would have been above sea level during the last glacial maximum, roughly 20,000 years ago. The discovery was reported by Reuters, covered by the BBC, and then, strangely, disappeared from the research agenda. No follow-up expedition has been publicly documented. In Japan, the Yonaguni Monument, a massive underwater formation off the southern tip of the Ryukyu Islands, discovered by dive instructor Kihachiro Aratake in 1986, features right-angled terraces, flat platforms, and what appear to be carved stairways at a depth of roughly 25 meters. Masaki Kimura, professor of marine geology at the University of the Ryukyus, spent over 15 years studying the site and concluded that it is at least partially man-made, with modifications dating to roughly 8,000 to 10,000 years ago. A Boston University geologist, Robert Schoch, who dived the site personally, agrees that some features appear artificial, but argues that the formation is primarily natural with possible human modification. The pattern is consistent: submerged sites. anomalous formations, evidence of human activity at depths that correspond to coastlines that existed during or just after the last ice age. Each site, individually, can be debated. Collectively, they point toward a possibility that mainstream archaeology has been reluctant to confront. That human civilization, not just human existence, but organized, building, measuring, engineering civilization, may be significantly older than the oldest cities we currently recognize. The builders had no names. Their cities, if they existed, are underwater or buried. Their knowledge survived only in the structures they built on high ground. Structures like Göbekli Tepe, like the Sphinx, like the megalithic foundations beneath Baalbek, where time and water couldn't reach them. Science, mathematics, and time. If ancient builders were encoding knowledge in their monuments, the question becomes, what kind of knowledge and how do we read it? The answer increasingly is mathematics, because mathematics is the one language that doesn't change. Words evolve, symbols are forgotten, cultural contexts vanish, but pi is always pi. The golden ratio is always 1.618. The speed of light is always 299,792,458 meters per second. And that last number is where things get genuinely strange. The latitude of the Great Pyramid of Giza is 29.9792458 degrees north. And the speed of light in a vacuum is 299,792,458 meters per second. The digits match to 9 places. The probability of this being a coincidence is not zero, but it is small enough to make mathematicians uncomfortable. And it raises a question that has no easy answer. Did the builders of the Great Pyramid know the speed of light? The standard response is no, that the meter wasn't defined until the 18th century, and therefore a correspondence between latitude and a measurement expressed in meters is meaningless. This is a fair objection, but it assumes that the builder's unit of measurement bore no relationship to the metric system. And that assumption is undermined by the pyramid itself, which encodes the dimensions of the Earth with extraordinary accuracy. If your unit of measurement is derived from the planet's geometry, as the meter originally was, defined as 1/10,000,000th of the distance from the equator to the pole, then the correspondence becomes less coincidental and more structural. Whether or not the latitude-light connection is intentional, the mathematical encoding of the Great Pyramid is not in dispute.
At the mathematical knowledge that is encoded into the Great Pyramid, the measurements that are used in it, even the placement of the Great Pyramid has aroused great interest among Egyptologists.
John Anthony West, the independent Egyptologist who spent decades studying the monuments of the Giza Plateau, documented these relationships extensively in his work Serpent in the Sky, building on the earlier research of R.A. Schwaller de Lubitsch, the French philosopher and mathematician who spent 15 years measuring the Temple of Luxor in the 1930s and 1940s. A. Schwaller de Lubitsch concluded that the temple's proportions were governed by the golden ratio and by harmonic relationships derived from musical intervals, that the building was, in effect, a mathematical composition expressed in stone. These observations were dismissed for decades as mysticism. Then the measurements were checked, and they held up. The Parthenon in Athens, built in the 5th century BC, incorporates the golden ratio in the proportions of its facade. The height-to-width relationship of the front elevation conforms to 1 to 1.618, with remarkable precision. The design also employs entasis, a subtle curvature of the columns and platform that corrects for optical illusion, making the building appear perfectly straight to the human eye. This technique requires not just aesthetic sensitivity, but a mathematical understanding of perspective, optics, and the geometry of visual perception. In Mesoamerica, the Pyramid of the Sun at Teotihuacan has a base perimeter of approximately 893.5 meters and a height of roughly 71.2 meters. The ratio of perimeter to height yields a value close to 4 pi. The same geometric relationship encoded in the Great Pyramid of Giza on the opposite side of the Atlantic, built by a civilization with no known contact with Egypt. Coincidence? Perhaps. But coincidences have a way of accumulating. And when the same mathematical constants appear in monumental architecture across multiple continents, separated by thousands of miles and thousands of years, built by cultures that supposedly had no communication with each other, and the word coincidence starts to feel like a placeholder for something we don't yet understand. Secrets buried by time and power. Not all hidden knowledge is hidden by accident. Some of it is hidden on purpose. In 1993, German robotics engineer Rudolf Gantenbrink sent a miniature-tracked robot called Upuaut 2, named after the Egyptian deity who opens the ways up the narrow southern shaft of the Queen's Chamber in the Great Pyramid. The shaft, barely 8 inches square, had been known since the 19th century but never explored. 65 meters up the shaft, Upuaut 2's camera revealed something extraordinary. A small limestone door fitted with 2 copper handles, blocking the passage. The discovery was reported at a conference in Rome. It generated enormous public interest. And then, remarkably, Gantenbrink was denied further access to the pyramid. The Egyptian Supreme Council of Antiquities, then headed by Zahi Hawass, took control of further exploration. It would be 9 years, until 2002, before a follow-up robot, Pyramid Rover, drilled through the first door on live television, only to reveal a second door behind it.
Just a quick overall video today. The Queen's Chamber, the Great Pyramid of Giza, okay, the air shaft, whatever you want to call it. I know it could be many things inside the Queen's Chamber. Now we see this weird red marking on the left.
That second door was breached in 2011 by a third robot, Jedi, which inserted a fiber optic camera and found red hieratic symbols, the first markings ever discovered in these shafts, painted on the floor behind the door. What was behind those doors? After nearly 2 decades of robotic exploration, the shafts remain unexplored beyond the second blocking stone. No public report has explained the hieratic markings. The shafts do not serve any known structural or ventilatory function, or their purpose remains officially unresolved. And the Queen's Chamber shafts are not the only sealed space in the Great Pyramid that has resisted investigation. In 2017, the Scan Pyramids Project, an international collaboration using muon tomography, a technique borrowed from particle physics that detects density variations inside solid structures by measuring the paths of cosmic ray muons passing through them, announced the discovery of a previously unknown void above the Grand Gallery. The void is at least 30 meters long, roughly the length of a commercial airplane. Its exact dimensions, shape, and contents are unknown. It is the largest internal space discovered in the Great Pyramid since the 19th century. The announcement, published in Nature in November 2017 by a team led by Kunihiro Morishima of Nagoya University, was met with excitement by physicists and caution by Egyptologists. Zahi Hawass questioned the methodology. Other scholars urged patience. As of today, no physical exploration of the void has been conducted. It sits inside the pyramid, sealed and silent, its existence confirmed by particle physics, but its contents unknown. This pattern, discovery followed by restriction, excitement followed by institutional caution, repeats across multiple sites and multiple decades. The Sphinx enclosure has been the subject of seismic surveys suggesting subsurface chambers beneath and around the monument. Thomas Dobecki, a geophysicist working with John Anthony West and Robert Schoch of Boston University in 1991, detected a rectangular anomaly approximately 12 meters below the left paw of the Sphinx, consistent with a man-made chamber. Proposals to investigate further were denied. Beneath the Sphinx, behind the doors in the shafts, inside the void above the Grand Gallery, in the unexcavated 95% of Göbekli Tepe, in the flooded ruins off the coast of Gujarat and Cuba and Yonaguni. The knowledge is there. The question is whether we're being allowed to find it, and whether the institutions that control access to these sites are more interested in discovery or in managing what gets discovered. Enduring intelligence. So why does any of this matter? It matters because the story we tell about ourselves, the story of how civilization began, how knowledge developed, how we became what we are, shapes everything. It shapes what we think is possible. It shapes what we look for and what we ignore. It shapes whether we approach the past with curiosity or with condescension. The standard narrative says that history is a straight line, that we are the smartest humans who have ever lived, that the past was populated by people who were fundamentally less capable, less knowledgeable, less sophisticated than we are, that everything worth knowing was discovered recently by people like us, using methods like ours. The evidence says otherwise. The evidence says that people 12,000 years ago could organize the labor of hundreds to build monumental architecture without agriculture, without metal, without writing. That people 4,500 years ago could encode the dimensions of the planet and the constants of mathematics into a stone structure that has survived 45 centuries without maintenance. That people 5,000 years ago could align massive structures to celestial events with a precision that modern instruments struggle to improve upon. These are not primitive achievements dressed up in mystical language. These are engineering accomplishments, measurable, verifiable, repeatable, and they demand an explanation that the standard timeline does not provide. The relevance to the present is direct and urgent. We live in a civilization that believes it is the peak of human achievement. We build with steel and concrete and assume that nothing before us could compare. We measure with satellites and lasers and assume that no previous measurement system could approach our precision. We store our knowledge digitally and assume it will last forever. But the Great Pyramid has been standing for 4,500 years, where our oldest digital storage media degrade in decades. The Göbekli Tepe carvings have survived 12 millennia of burial and exposure. Our cloud servers require constant electricity, cooling, and maintenance. The stone circles of Britain have kept their alignments for 5,000 years. Our GPS satellites have an operational lifespan of about 15. Who is really building for the future? Who is really thinking long-term? The ancient builders encoded their knowledge in the most durable medium available, stone. They chose mathematics as their language because mathematics doesn't decay, doesn't require translation, doesn't depend on cultural context. They built structures that would survive anything, flood, earthquake, empire, neglect, and carry their message forward to anyone capable of reading it. Yet we are only now becoming capable of reading it, and the message, as far as we can decode it, seems to be, we were here. We understood more than you think. Pay attention. The stones have been speaking for thousands of years. Pi, the golden ratio, lost civilizations, buried knowledge. They are all etched into the architecture of the past, waiting for someone who can read them. And yet, for all we have uncovered, the story is far from complete. Hidden chambers, submerged ruins, unexcavated hills. The Earth still holds secrets that could rewrite history once more. The question isn't whether there is more to find. The question is this: when we finally uncover it, will we understand what it is trying to tell us?